This wasn't just a scientific discovery. It was a violation, a gap where a partner element should have been. Iron was missing. It was as if someone had wiped it away. Now, it's easy to dismiss these as errors, anomalies, false positives. They happen. Data gets corrupted, instruments malfunction, cosmic noise tricks algorithms. It happens. But this case didn't fit those explanations. Too many instruments, too many checks, too many independent analysts all returned the same result. The data was corroborated, verified, validated. Each step of the way, the iron signature disappeared. And as the data sets expanded, so did the mystery. More elements started going missing. First, silicon dioxide, then magnesium and calcium oxide. After that, hydrogen, oxygen, and sodium. And with each loss, the comet's identity slipped further from view. What was happening? Was this thing shedding mass? Was it being dismantled atom by atom? The answer came on August 13th from the most unlikely source, a robotic car named Opportunity that landed on Mars almost 20 years ago. As NASA's Perseverance rover investigated Jezero crater, it happened to turn its Mastcam Z toward Comet 3I Atlas. What it saw was this, an incredibly faint but distinct flash of green. In theory, this should have been impossible. Perseverance was looking through a telephoto lens optimized for rocks and dirt, not fleeting photons. And yet, right there imprinted on the Martian sands was a 1.2 millisecond spike of light that should not have existed. But there was no atmospheric distortion, no particle interference, no sensor flare. It was a perfectly sharp photon burst, an unfiltered spike that matched the spectral signature of sodium. Of course, this wasn't really about sodium. It was about what the detection meant. To understand that, let's go back to August 7th, 2 days after the override. While Webb tracked the coma and the orbit, 2 other observatories watched the nucleus. The 60-meter dish of the Green Bank telescope focused radio waves on 31 Atlas. Meanwhile, the ALMA radio array trained 66 high-powered beams on the speeding comet. Both experiments found strong evidence of volatile materials, and both were baffled by one key detail: the absence of hydrogen. Remember, this was the point where Webb had just detected the first signs of carbon dioxide. Scientists suspected that beneath the coma's fuzzy shell, something colder and harder was lurking. 3 days later, their suspicions were confirmed. The Keck Observatory mounted a camera on the summit of Hawaii's Mauna Kea and captured an image of 3I Atlas. Instead of a featureless blob, it saw a jet contrail, a narrow dark line protruding from the nucleus, a sign that underneath the hazy coma, the core of this thing was hard. It was emitting gas through some kind of hole. It was venting. But here's where things got difficult. All models of cometary outgassing predict a puff. The gas is supposed to fan out immediately upon reaching space, dispersing into a coma faster than it can build up. Yet here the contrail was straight and sharp. It wasn't a puff. It was a beam, a pressurized burst moving with incredible speed. It was as if the comet was drilling a hole in space itself. The breakthrough came a day later on August 10th, when the ALMA team checked their instruments against a newly minted catalog of 3I Atlas. They wanted to see if the jet kinematics modeled the actual velocity. They also wanted to confirm that they weren't picking up any unexpected elements. The first part went fine. Their simulations matched the coma fairly well. Then the second check arrived, a number that nobody expected, 0.03%. That figure represented the fractional abundance of silicon. 3I Atlas had kicked out more silicon than it emitted all other elements combined. And if that wasn't enough, the next data packet arrived on August 11th. This time, it was sodium. The object had released 4 times more sodium than silicon. By August 13th, the picture was complete. What astronomers were witnessing wasn't a comet at all. It was a geyser. 3I Atlas was ejecting a stream of material, not from heat or solar radiation, but through an internal mechanism. Some kind of hidden engine was depressurizing the interior, blasting a fresh plume into space every 7.2 hours. But even that revelation couldn't touch the biggest surprise left in the data, the one that still has scientists scratching their heads. The nickel-iron conundrum. 3I Atlas was the first object ever seen to expel pure nickel. It was breaking the fundamental rules of elemental chemistry. For over a century, every nickel-bearing meteor and comet had shown the same thing, a tight coupling with iron. The two metals come from the same forge, the same density, the same magnetic properties, the same condensation temperature. They always appear together, until 3I Atlas, that is, which showed no iron whatsoever. And now, even with gas gazers in play, the puzzle deepened. When the first disintegration spectra arrived, they were baffling. Webb's near-infrared camera searched for organic molecules like methane and methanol, molecules that should have been abundant given the object's CO2 emissions. But it found nothing. All it saw was more nickel. With every passing day, the nickel spiked higher, steadily climbing over 10 to the 21st atoms per second. That's not just a lot. It's unheard of. Nothing in our solar system releases nickel that fast. Nothing except a manufactured thing, something releasing its payload intentionally. And that's where we stand today. We've watched a geyser erupt through a coma, spew out pure nickel, and vanish into the vast emptiness of deep space. We don't know how or why or even if it's sending messages. But we do know that something changed up there. 3I Atlas isn't just visiting our solar system. It's woken up in it. And whether it's sending signals or not, we'd better learn how to answer them. So here's what you need to do. If you want to learn more about the amazing technology that makes these amazing discoveries possible, subscribe to the channel and tap the bell icon. That way you'll get notified the second the new video drops. Okay, class dismissed. You're free to go. Thank you for coming today. Oh, and watch your step. There's a comet outside.